Following on from the previous video, here's my second attempt to explain the precise definition of a limit. Now, in the previous video, it doesn't matter if you don't fully understand it. We are not going to fully try to understand this whole thing here. We are just going to try and understand the concept and the idea behind it. Because for you to fully understand something like this and something like this here, you will need to be given exercises to really test you on these two concepts. But that's for when you're older. But for the time being, let's just try and understand the idea and the concept behind it. So, for example, let's say we want to find out. Well, we want to know this at x equals 0. But the thing is, at x equals 0 here is undefined. So what we can do is we can head towards 0. So the point behind this here is that you give me the accuracy. Well, it's saying, roughly speaking, it's saying you give me a number epsilon here. This is really in a way, it's like the accuracy of the limit. You see, dead on 0, we down here we cannot evaluate this. We cannot evaluate this dead on 0. But let's suppose you give me an epsilon. You give me a number here, e here, epsilon here. You give me an epsilon here. Well, you give me an accuracy at which you want your answer to be. And then I will come up with another number, delta here, that will guarantee you to get within the accuracy at which you want it. So, for example, I know it sounds confusing, but just hold out on this. Just try and understand it. So you are trying to evaluate this at x equals 0. But the thing is, at x equals 0 is undefined. So what the idea is behind the precise definition of a limit is that you give me a number, you give me you give me an accuracy at which you want it, which is called epsilon. You give me the accuracy at which you want it, and I guarantee you I will allow you to get within within your precision. So here, let's say you want it to an accuracy of, let's say, this much here. Okay. You see, here you're saying that, okay, I want it to, let's say, within 0.00001 here. Let's say you want it within this accuracy here. You see, I can guarantee you that you can get within this accuracy by me telling you to edge towards this 0 here. Get as close as you can to the 0 here, and that will guarantee you to get to within the accuracy at which you want it. So, for example, let's say you want it within this accuracy here. I'm saying, okay, evaluate it at minus 0.0001, and then you would guarantee to get within your accuracy. Can you see that? Let's say you want it within let's say this much of an accuracy. Let's say that there are some other numbers here. Well, I can guarantee you, I can guarantee you will get within your accuracy if you choose to evaluate this at, let's say, minus 0.00000. You see, I can keep on edging towards. My point here is that we know that the limit here is it's heading towards 1, but let's say you want it within an accuracy of 0.0000 whatever. Let's say you want it within this much accuracy here. So it can be up here, it can be slightly down here, but within this level of accuracy here. Then I can just edge towards the 0 here and get within the accuracy at which you want it. So my point is that no matter how accurate you want it, let's say you want it no matter how accurate you want it, I guarantee you I can tell you to evaluate it. Let's say edge. I'm just saying edge to as close as you can towards 0. Let's just say this, and then that will then guarantee you to get to within your accuracy. My point is that no matter what level of accuracy you want it, it is always possible to get it within your accuracy by edging towards zero here, by getting as close as you can. The thing is, we can always head towards zero. We can always get closer and closer and closer and closer and closer to zero. It's just that dead on zero. You can't have it at dead on zero, but you can always get to really close to zero. And when you get really close to zero, then you eventually you will get to within the accuracy at which you want it. And I also gave you an example in the previous video of this. If you had a made up function like this, let's say z of x here, you see here you cannot have a limit, because suppose you want it within an accuracy of, let's say, of this here. You see, I cannot keep on edging towards zero. I have to stop after this stage here, and also after this stage here. I cannot keep on edging towards zero. So suppose you say you want it to an accuracy of 0.00000, let's say this much. You want it within this accuracy here. Then I cannot keep on. You see, I can edge towards zero here, but beyond this here, beyond this bit here, I cannot keep on edging towards zero, because it's, for this function, it's undefined. My point is that if there's a massive gap in between, I cannot keep on edging towards zero. So I cannot guarantee you to get to within the accuracy at which you want it, because there's a gap. Whereas if you're up here, I can keep on edging towards zero. I can keep on edging towards zero, and then eventually you will get to within your accuracy. Down here, I cannot keep on edging towards zero. I cannot keep on moving. I have to stop after this stage here. So my point is that when this here, it doesn't have a limit, but this up here, it does have a limit, because you can keep on getting within your accuracy. You can keep on getting within your epsilon here. This is your level of accuracy here. You see, whatever you state here, if the limits truly exist, then I can keep on edging towards A here, and then eventually I can get to within your accuracy, within your desired accuracy. I hope you fully understand. Well, anyway, that's my best attempt to explain the idea behind limits. Okay.